Hello, I'm Richard Ruhala.
And I'm Laura Ruhala, Rich's wife and colleague. We're both mechanical engineering professors at Kennesaw State University, located just outside Atlanta. Our co-authors are Anahita, Danny, and Andrew. They are each undergraduate mechanical engineering students, as well as our colleague, Professor Lance Krim.
Our topic is acoustical transmission of face coverings in a classroom environment. During the COVID-19 pandemic, we've all been required to wear face masks to reduce the spread of the virus. The side effect is some kind of muffling or change in speech. We wanted to quantify this acoustic effect, and so we tested 12 different masks and shields.
Okay, the first graph here, we're looking at acoustic attenuation versus droplet transmission. On the vertical axis, the higher the number, the worse it is acoustically. On the horizontal axis, the higher the number, the worse it is from a droplet transmission standpoint. This is from Fisher. So the first mask, the N95, is really good from droplet transmission, but not so good acoustically. Just opposite that would be the Gator, which is great acoustically, but really bad from a droplet transmission standpoint. We have this blue dot here. That was an apron cloth mask, which was great for both, but cloth masks are they really vary in their properties. If you want a standardized mask, the surgical mask was good, both from a droplet transmission and an acoustic standpoint.
We did our testing in a classroom on Kennesaw State University campus. We used a head and torso simulator, which produces sound out of the nose and mouth, where speech signals as well as white noise or other sounds can be played. We used a sound level meter to measure the sound at different locations in the classroom. Our testing was done in a 40-seat capacity classroom. Testing was done on the weekends with the HVAC system turned off. We surveyed sound or measured the sound level at every seat with the acoustic simulator sitting up at the front, or standing up at the front where the instructor would be normally. And we also measured at 2-meter distance for detailed frequency analysis, as well as 6-meter distance.
All of our graphs are going to show data from the white noise at 2 meters out. Okay, the first graph, the 0 line, that's the hats without a face mask on. So the hard plastic mask, that's this one right here, it actually amplified the sound significantly. And that was, I guess, the best one, but there's more to that. We're going to loop back to that. There's more to that story. The N95 was the worst mask performance, looking at the A weighting with a 4 decibel reduction. Okay, now the next set of graphs are all going to be set up the same. On the vertical axis, we're looking at the acoustics, and on the horizontal axis, we are looking at the frequency ranges, looking from 250 to 8,000 hertz, which is where human speech would lie. Cloth masks, they all showed an attenuation at the higher frequencies. This means a sound reduction. Similarly, the disposable mask had something very similar. And you can see the surgical mask, though, was better than the counterparts. Especially bad was the KN95 with the exhalation valve. The face shield had an interesting effect. The blue line is an N95, the green line is just the face shield, and the red line is the face shield on top of an N95. Notice the amplification at 1,000 hertz. And the face shield actually even amplified the N95. But then you also had this attenuation. In fact, every mask we tested that had plastic showed the same amplification at 1,000 hertz and then the attenuation after. This could really cause some speech distortion.
Next, we're planning to evaluate the acoustic data already collected, but instead of white noise, using artificial speech and real speech recordings. Then we're going to conduct a listening study with binaural measurements to quantify the speech intelligibility. And finally, compare the HATS testing with human talkers.
Again, I'm Laura Ruhala.
I'm Richard Ruhala.
Thanks for listening.